Greetings, welcome to my demonstration here. This is a macOS native desktop software-defined radio application using the RTLSDR USB device as the hardware. Couple things I want to point out here before I get started. I did not write a driver, a macOS driver for the RTL device. I am simply using the standard C library, librrtl-sdr. Second, it's all written in Swift, specifically targeting the Mac using the Mac frameworks, but this code will never see the light of day. This basically is me learning Swift and learning Macintosh desktop applications. So a lot of what you see here is me doing what ifs. So what happens when I do this? What happens if I do this? So it's just basically a lot of experimentation and seeing what works, what doesn't work, and what effects I can get with how I envision it. With that said, I will point out that I am working on a separate application that will be something that's going to be released as soon as I get it to a first release point. And same concept, all the stuff I'm learning writing this application, I am putting into that application, and I'll give a quick overview here at the end. So let's go ahead and get started. I'm going to select my RTL device here.
Highs in the lower 50s. Chance of measurable precipitation for Seattle. West of today, 90. Tonight, there is a chance of rain showers. West 24. La Parus.
Well, there you can see that I was decoding NOAA weather radio. You can see there's several channels that I can pick up in my area. These little blips over here, these are the AIS system used by ships at sea. These are coming off the ships that are out in Elliott Bay. Let's go to the next step here.
Boeing report information, Oscar 2153 Zulu, wind 180 at 6, visibility 10, light rain, 3,000 scattered, ceiling 5,000 broken, temperature.
All right, there was Boeing Field's automated traffic information service. That's AM aircraft band, so we've seen FM and AM broadcasts going on. Let's go to the next step here. Now this I will point out we can't listen to. I don't have any way to demodulate FM broadcast. You can hear it's, there's noise there, but I just don't have the filter and the algorithm set up to do it right now. The main reason I wanted to point this out is just so you can see the spectrum display here. Here we're looking at 1, 2, 3, 4 radio stations. I guess there's a fifth one on this side and a sixth one on that side. So technically we're looking at about 1, 2, 3, 4, 5, 6 stations. And I bet you there's another one right there that I've seen on different antennas at different locations. But anyway, it was just mainly just to see it. Get an idea of what my scaling functions do there, my scaling control does there. I usually keep it on auto where it pretty much stays at the bottom. Next step. Now hopefully I can get a transmission up in this range here. If not, I'll do it manually. While I'm waiting, I'm going to point out some of the controls here. Obviously you can see that I'm just selecting the device there.
No contact order.
All right, there we go.
Federal Way.
82.5. That's what I wanted to point out.
For drivers is showing ID only 2022 suspended.
Well, that 82.5 is the CTCSS subaudible tones. This is one of the public service agencies that still use voice repeaters that require the CTCSS tone to key up. My program listens to the audio samples, the audio packets, and runs it through an algorithm, a Gortzel algorithm, if I said that properly, to determine if there's any tones present, and if so, it will display that up there. So continuing on, frequency stepper here, the stepper control down there, signal strength versus squelch. That squelch percentage, that just gives you a good idea of how many packets are being squelched out, how many, if your squelch is fully open or fully closed, if you wanted to look at a traditional radio. Frequency correction, that just gets passed right onto the driver. This device is pretty good. I have a couple other devices that really require some tweaking of that. Gain, that again, these numbers come directly from the driver itself. A lot of times I have to turn it off, auto gain, just because some of the signals just overload the front end. You can see right there, somebody's keying up pretty close. It's just splatting all the way across the band there. Let's go to the next step. Again, we're on public broadcast range. These are all trunk channels up here. We may happen to, here we go.
2 injury from a fall, Northwest Eye Surgeon.
Basically, we're just going to listen to random voice channels or voice conversations as they pop up. Point here is you can see that each one of these spikes is a transmission. Some of them are data transmissions, like that one's a big data stream. That's obviously a control channel. You can see the ones that have all the structure in their waterfall. Those are voice channels. Let's get on with the next thing here. I was going to point out me experimenting with audio units, Apple's audio units. So I created a high-pass audio filter specifically for filtering out the subaudible tones, which, as anybody that's an amateur radio operator knows, even though they're subaudible tones, they're really not subaudible. You can hear them. Lastly, this controller here, this is for an external control panel. I don't have the circuit hooked up right now. I'm rebuilding it. That's going to be a separate post altogether, but just consider it being an external control panel, tuning dial, just frequency display, probably some fancy buttons. May even get courageous and pipe the raw audio feed down so you can listen to it through a little speaker there. I don't know, but eventually that'll become a topic all on its own. Next step here. Move that up. Most anybody who's used the RTLSDR should be familiar with the GQRX. Just want to show that this is using serial number 2. I'm connected to serial number 1. 2.4 megasamples per second. Let's go ahead and get started. I'm going to move these over so they line up as best they can. And yeah, look at that. Nice, perfect mirror of each other. Obviously our scales are off, but for the most part you can see the spikes relative to the other signals are just about as accurate on both sides. Waterfall display, same thing. You can see the displays falling down on both sides. Obviously, I need a lot of work to do on mine, but again, this is this program, like I said in the very beginning, will never see the light of day. It's just me doing a lot of experimentation, a lot of what if. I'm going to go ahead and stop this, close GQRX for my next demonstration. All right, let's go ahead and select that one. I don't have an antenna hooked up to this first one, so I'm not going to use that anywhere, but we'll use this one. Let's go ahead and just start it. So there we are. We got two different RTL devices connected. They're both connected, or they're both tuned to different frequencies. That works quite nicely. I can get 3 of them working, but I have found that because my waterfall display is very inefficient right now. I mean, this is revision 0.01. I just hacked it together a couple nights ago, and it works, and I haven't done anything with it since. But be that as it is, it's very inefficient, and I can only get about 2 of these going before the main thread that controls the user interface starts to slow down. Let me just go here and turn down the gain. And there we go. We got a nice mirror display. My whole thought on this purpose is, being an amateur radio operator, I want to be able to pull up at least 1 or 2 or 3 of these and watch an entire band, especially when I get into coding for a more high performance SDR. Right now I'm just using the RTL, but eventually I have plans on acquiring some of the better software-defined radio hardware, because this, I'll be the first to admit, is not a software-defined radio piece of hardware. It's a TV tuner that can give you raw IQ data, and you can manipulate it at that. Okay, so let me just go and show the last point of my demonstration here. I'll just keep that running. All right, I did mention that I have another one that I'm working on. Again, it's still a little bit of a learning experience for me, but I'm building it such that every component's been separated, everything's got their own function, it's all being documented. Let me go ahead and open this up a little bit here. You can see it's got a lot of the typical controls that you're going to expect to see. Tuner, a lot of what I've already had. Direct keypad entry, all the good stuff that I've been putting in my other ones. This big wide open area here is obviously going to contain the waterfall display and the spectrum analyzer. But this is one that's going to come along quite a bit more slowly just due to the fact that I'm spending more time actually engineering it as opposed to just doing a lot of what if code and sticking what works all together. One thing I would like to point out is that when I'm doing this, I'm trying to kind of have a same concept as working with Xcode itself. The buttons up here on the top bar, I want to have some controls over here as well, so you can basically get rid of the sidebar, maybe get rid of the display if you want to, put it in shrink mode. I don't know. It's all sorts of different options and ideas have been going through my head, but for now it's just more coming along slowly but surely, where any of my experimentation code is going into this one right here. This is where I just make it work, and once I know I got a working algorithm, then I can tweak it and tune it and change it to make it look better, make it more efficient, whatever it needs. So that's it. Thank you for watching my demo.